All right, let's dive in. Today, we're going to get our hands dirty and architect a really powerful, production-ready Q&A system from the ground up. And we're going to do it all using Retrieval Augmented Generation. You'll hear me call it RAG, right on Azure. So let's get building.
You know the problem, right? Every single company has it. There are just mountains of valuable information. We're talking HR policies, super detailed technical manuals, project histories, and it's all just locked away inside PDFs, Word docs, and spreadsheets. So how do we fix this? Well, we're going to design an internal Q&A bot that can intelligently tap into that exact knowledge base and give you the answers you need instantly.
Okay, so here's the game plan for today. First, we'll really define that internal knowledge problem. Then, we'll look under the hood at the anatomy of a RAG system. After that, we'll start assembling the blueprint on Azure, mapping concepts to actual services. Then comes the important part, hardening it for production. And finally, we'll put it all together in the final architecture.
So, what's the end goal here? It's actually pretty simple, but incredibly powerful. We want to create a bot where any employee can just ask a normal question, something like, hey, what is our company policy on international travel? And get an immediate, accurate answer that's pulled directly from the official company handbook, not just some random search result from the public internet. So how does this magic actually work? Well, the engine driving all of this is called Retrieval Augmented Generation, or RAG. It's this really clever process that combines the massive reasoning power of large language models with your own specific private data. Let's take a look under the hood.
At its heart, you can think of RAG as a four-step dance. First, we ingest all those documents. Then, we break them down into smaller pieces, or chunks. Step 3, we index those chunks for their conceptual meaning. And finally, when a question comes in, we retrieve the most relevant pieces and use them to generate a precise answer. It's kind of like having a super-powered librarian who's read everything, categorized it by idea, and can synthesize a brand new answer for you on the spot.
First up is this idea of chunking. Think about it. You can't just feed a 100-page PDF manual to an AI model all at once. It would be completely overwhelmed. So we have to be smart about it. We strategically break that document down into smaller, digestible paragraphs or chunks. The goal is always the same. Create these little bite-sized pieces of text where each one carries a really focused and specific piece of context. Next, we get to my favorite part, the vector index. And this is really the system's brain. Now, this is not your typical keyword search. A vector index doesn't just look for words, it understands the meaning and the context behind them. This is what lets the system find a relevant chunk of text about, say, working from abroad, even if a user asks a question using the phrase international remote work. It's a total game changer.
All right, enough with the theory. That's all great, but let's get practical. How do we actually build this thing on Azure? It's time to start mapping each step of our RAG process to a specific, powerful Azure service.
So, step 1, ingestion. Where do all of our raw documents go? The PDFs, the PowerPoints, the spreadsheets, you name it. They all get uploaded into Azure Blob Storage. It's the perfect starting point. Massively scalable, secure, and cost-effective. It's our digital library shelf.
Next up is the heavy lifting. This is where Azure AI Search comes in. It's an absolute powerhouse of a service. It connects directly to our blob storage, and it handles all the tough stuff for us. It cracks open the documents, does that chunking we just talked about, and then it builds that incredibly important vector index. It does all of that automatically. And finally, we get our answer. When a user asks a question, Azure AI Search zips through our index and finds the most relevant chunks of text. Then, and this is the key part, it passes those chunks along with the user's original question to an Azure OpenAI model like GPT-4. That model then uses that very specific context to write a perfect, accurate, and genuinely helpful answer.
Now, if you connect those three services, Blob Storage, AI Search, and OpenAI, you'll have a fantastic proof of concept. It'll work. But taking it from a cool demo to a real enterprise-grade, production-ready solution, well, that requires us to put on our senior architect hat and start thinking about the really hard stuff.
And believe me, the leap from a proof of concept to a production system is huge. A POC might have totally open access, but a production system absolutely needs fine-grained security. A demo can be a little slow, nobody really cares, but a real application has to be fast and optimized. And while a demo just has to kind of work, a production system has to be monitored, reliable, and observable from end to end.
This right here is probably the most critical question for any company looking to build this. How do you make sure that, say, a junior engineer can't ask the bot about sensitive HR salary data?
The answer has to be that users only, and I mean only, see answers that come from documents they are actually authorized to view. This is non-negotiable.
You've basically got two main strategies for tackling this. On one hand, you have per-user filtering. This is the most secure approach, where every single search result is filtered based on that individual's exact permissions. It's airtight, but it can get complex to manage. On the other hand, you have per-group filtering, where access is controlled by roles like HR, engineering, or legal. This is often way simpler to manage and might be good enough for many use cases.
Okay, so security is handled, but we're not done yet. Your production checklist needs a few more critical items. You have to constantly manage the AI model's token limits to make sure you don't send too much context and cause an error. You have to obsess over latency because nobody wants to use a slow bot, and you absolutely must have observability. That means logging everything so you can track performance and debug issues the moment they pop up.
So, after we've thought through all those production requirements, security, performance, reliability, what does the final blueprint actually look like? Let's combine everything we've talked about into our complete, production-ready reference architecture.
Now, before I show you the full diagram, it really helps to think about it in 4 distinct zones. First, you've got the ingestion subsystem, which is where all our data comes in. Then there's the indexing subsystem, where all the processing happens. You've got the application layer, which is what the users actually interact with. And then, wrapped around everything, you have the security and monitoring overlays.
And here it is. This is the final blueprint. The core data flow you can see is still pretty straightforward. It goes from storage through AI search to the OpenAI model. But the real key to making this production ready isn't that flow. It's the layers that wrap around it. You can see those security layers actively filtering every single query for access control, and you can see that observability layer monitoring the health of the entire process. That combination is what makes an architecture truly robust.
So what's the big takeaway here? Please, don't try to build this entire complex production system on day one. The absolute best approach is to start simple. Build a quick proof of concept to show the value and get people excited. Once you've got that buy-in, then you can start to incrementally add these crucial production features like advanced security and deep monitoring.
So there you have it, a complete blueprint for unlocking all that knowledge that's trapped inside your organization. The architecture is robust, it's secure, and it's built to scale. The only question left for you is, what problem are you going to solve first?